Good morning, good afternoon, good evening. This is ABSO technology. So now today I just want to explain in details how you can fuse a stabilizer board that is totally dead and replace it with ABSO board. This ABSO board for the ABSO technology. You can contact us if you need this board. So it's readily available. Now today I want to use power boost paper. You can see this is the maker. Power boost automatic photo regulator is a 2000 watts. You can see it on the cabinet 2000 VA. So the cabinet. So now let me open the cabinet. So now please listen carefully now. So the first is to remove this board. This is dead board. You can see it clearly. The board is totally condemned. So I want to remove it and replace it with absolute board, new board now. So let me start removing the tap. So now I've removed the dead board now. So what you now do is this. This is the transformer. If you count the number of taps, we have 1, 2, 3, 4, 5, 6, 7. So this is a 7-tap transformer. So there are different means through which you can identify the tap. So the standard one, so I will show in different means. Just follow my page, like and share. So and on my page I will be uploading video on how to determine the tap and how to identify it easily. So but the first method I will introduce today is using footage. If you observe this transformer very well now, you notice that this winding, this tap is the starting winding for this transformer, while this one is the last tap. That's the end turns, the ending winding of this transformer. The starting winding, the last one, the start and the end. So what you now do is this: you collect the start and the end to the power supply to 230. So let me do it now. I'm collecting it to power source. Please listen very well now, please. For those of you requesting for video on how to easily identify the tap. Winding, this is the end, the end. The last tap, this is the first tap, innermost one. So you leave this one alone now. So now plug it to the electrical outlet. So I'll plug it now. The first is to measure the supply voltage. You can see that it's 231 volt now. So I'll supply this transformer with 232 volts. Are you with me now? So now you now place your negative probe. You leave it on the first winding. Then you start to measure the other winding in respect to this tap. So if I start now, I leave my probe here. This is my positive probe, this is my negative probe. So I leave my probe here, then I start from here. You can see it's 12 volts. So this 12 volts, this 122, 127 volts, 155, this 155, this 190, then this 210. So if you look at it very well, you see that the voltage increase gradually from here: 12, 127, 150, 155, 190, 210. Then the last one, the supply tap, is 232. Now on the board, the voltage starts from 0. This one will be collected to 0. This tap here will be collected to 0, which is 1. This one that reach 12 volt will be collected to 12.5. You can see it clearly. 12.5. Let me choose another one. Sorry. Collected to number 1, which is 0 volt. The one that supplies 12 volt will be collected to number 2, which is 12.5. You can see it clearly. So 12.5. Then the one that supply what voltage? 122 or 125 will be collected to 122. You can see it has been labeled. Then the one that supply 150 or 155 will be collected to this. Then the one that supply 190 will be collected to 192. Then the one that supply 210 will be collected to 215. Then the last one will now be collected to 240. So that's how you easily collect it. So let me measure the voltage again so that I can get it clearly. Starting with this, do not forget that you leave this probe on the first tap. So we measure this 12 volt. So this 12 volt now we go to 12 volt on this board. We go to 12 volt on this board, this one now. Then the second one now, which is 127, we go to this 122. Then the third one, which is say the fourth one now, which is 156, you go to 153, then 189, you go to 192, then 210, you go to 215, then the last one, you go to 240. So that's how you collect it. So let me now start to collect it one after the other. This for the power supply. So let me now start. This is the one, two. Okay, let me use the reader. So this one will now be collected to 0 volt neutral. Please follow my page, like and share. And you can also save this video. So I've collected it. I've soldered it now. Then this one measure 12 volt. So you collect it to 12.5 volt here on the board. Then this one to 122. Then this one to 153. Do not forget I will measure it. Then this one to 182. Then this one now to 215. Then the last step now to 240. So we have collected all the tap to the board now. So now if you look at this place, this is the output socket. You will now notice that the output socket here, this terminal is connected to the neutral. This is the neutral wire. The live wire of the power supply comes here to the switch. The neutral is connected to this tap. The live of the power supply is connected to this switch. So this neutral now connected to this terminal from this wire to this terminal. Then this wire now carry it here. So this is wire now. This wire now, this is the neutral wire of the supply. So this wire represents the neutral for the input voltage and also the neutral for the output voltage. So both neutrals will be collected together. The neutral for the input power supply, the neutral for the output socket. So let me now collect it now. So it will be collected together with this tab with N. You see N/0. Here. So I've soldered it now. So now this other tap, this other cable wire is the output socket live. You know the neutral has been collected together, so the live wire is separated. So now you now collect this wire carrying the supply, the live to the output. You see out on the board, out live. So you now collect it here. So we have soldered it now. Now the input live, it remains only the live for the input. Let me solder this thing very well. So the live wire from the input, that this is the live wire from the input to the socket, to this switch, on and off switch now. Will now be connected to the input. You see input, IN live, input, so input live. So you now connect it to input live. So now we have collected everything together now. It remains only the indicator. Now out of all these indicators, you only need the in use and the delay. Also the delay switch. In use, that will be the power, delay, then the delay switch. So let me remove it first. So now, while you're using this, any resistor you find on this board, on this indicator side, just disconnect it. Disconnect all the resistor. Then on the board, for the indicator, you will find, where is this? You will find D IND, that's delay indicator for delay indicator. Then PWIND, that's power indicator. Then this switch SWD is for the switch for the delay. So you collect between this terminal and this terminal for the switch delay. Then this positive and negative for the delay indicator. Then this positive and negative for the power, which is the in use indicator. Now another thing is that all the negative and ground on this board is collected together. So it's only the positive, this SWD, then the positive here that is separated. So a wire can represent the three: ground, the negative here, and the negative here were collected together on this board. So now let's now try it now. If you see on this bulb now, this LED, this is a light emitting diode. Just locate the negative side. This is the negative side for this one, and this is the negative side for this one. So what you now do is that since you know the negative side for this one, let me put it back in place. This first wire goes to the second switch, which is the turbo switch. So you don't need the turbo, you remove it. So this one, now you just select this. This is the positive for this. That's the in use LED. This is the red LED in use. Then this one is the ground. So you can connect it to the ground here, which is the negative. Do not forget that ground and the negative here were connected together. Then this for delay switch. This one is connected to the delay button, while this one is connected to the delay LED. So now the delay LED negative is not connected to the ground here. So you have to bead it. You have to use a jumper wire to do that. Use a jumper pin. So now this is our ground and the negative. So we now connect it to the ground here. So we now connect it to the ground here. So the ground wire for the indicator. Then the wire for the delay switch, for the delay button, you connect it to the SWD. That is the delay switch. Switch for delay. SWD means switch for delay. Then the cable for the delay for the in use, that goes to the power indicator. You connect it to the positive. Then the delay indicator, for this delay indicator, now connect it to the DIND. DIND means delay indicator. DIND on the board. So delay indicator. So now after that, this is the meter, this is the output meter, this is the input meter. The input meter, this side is connected together. Then this side So now this side is connected to the output meter. You connect it to the output wire, the wire supplying the output socket. Then now look for a wire, the cable to collect this one, this terminal. So this terminal, we connect it to the zero source, the n/0 source on the port. So then do not forget that immediately you finish the collection, remember to collect the mounting metal to mount the board firmly on the. So let's say I want to use this. Then once you want to mount the board on the inside the cabinet, make sure you mount it appropriately so that it moves a little bit back, so that it doesn't touch any of this. So let me mount it now. Let me collect this thing. So now, let's test this stabilizer now. We have finished the connection, so let's test it. So where give the plug it. So I've collected it now. So this meter is not working again. So you can replace the meter, but the meter is not working. It's even on 100 foot when I've disconnected the power. So the meter here is not working. So let's connect it. You can see that the LED is blinking now. Now, if the LED is blinking very fast, it will delay for 5 seconds before supplying the voltage to the output. But if the LED is slow, it's blinking very slow, it will delay for 99 seconds. So let me disable the delay now. I've delayed it. You can see the rate will change. So the rate have changed now. So it will, after 5 seconds, it will supply the voltage out. So the meter here is now working. So let me test it with my lamp. You can see now the bulb is up. So let me off it again. So I want to restart it. So it's now working perfectly. So just contact ABSO Lab Technology. We have for 5,000 watts, 2,000 watts, 8,000 watts bulb. So just only this for 5,000, 8,000 watts stabilizer. So contact ABSO Lab Technology and follow for more updates. I'll still be uploading video on stabilizer and inverter. As time goes on, follow my page, like it and share. So this is very easy to use and it's very easy to collect. Thank you.
Very neat and perfect. Tested and trusted.